Okay, so good morning, everyone, or good afternoon, or good evening, depending where you are, I guess. Welcome to this first session on meta studies. We have a very interesting program today in the session. We have 7 different papers. We have journal first papers, 4 journal first papers. We have a new ideas paper. We have a technical research paper. We have a tool demo, so you should expect a lot of interesting talks, and we also hope quite interesting discussion during the session. In case you haven't seen the introduction videos and how to use the Clouder app, even though ICSI is a bit different this year, we still want to facilitate discussion in the sessions and have people asking questions to the presenters. So in case you're not already logged in, please log into the Clouder app, and on the left-hand side of this app, you can find the Slido panel. And in this panel, you can post questions at any time during the presentation. And a few hints, please don't forget to add your name there if you want to let the presenter know who is actually asking the question. Otherwise, the question will be posted as anonymous. And the other thing is, please don't wait until the actual presentation is over. At any time during the presentation, when you have a question, just post it there. And shortly before the presentation ends, we will select a couple of these questions and then ask them to the presenters, and they have time to answer. And the questions won't be lost, so please just ask the questions, even if they don't get answered during the session. The presenters and the authors can come back to the Slido and then answer the questions afterwards. And since we have 7 papers in a 1-hour slot, we do have a quite tight schedule. And I think in order to get the session started, without further ado, let's announce the first presenter, which will be Xin Chu from Nanjing University. And he will present a technical paper on the use of gray literature in software engineering. Xin Chu, please go ahead with your presentation.
Okay, I will share my slides. Hello, everyone. It's my honor to participate in this virtual meeting of ICSI. My name is Xin Zhou from Nanjing University. The title of my research is an evidence-based inquiry into the use of gray literature in software engineering. Recently, but I can't. Oh. Recently, gray literature has shown the potential to become an important companion in software engineering research, while at least it has become an important source of information in industry settings. Gray literature can also be an effective supplement to white literature for research. We can see the picture, gray scales of the literature. The innermost layer is white literature, which makes up only a very small part of the literature, out of which gray literature can be divided into 3 scales. The outer the level, the more the quantitative, and the more difficulty to control. As the objective of this work is to empirically explore the views of the software engineering researchers about gray literature. We set up our research questions to investigate the use of gray literature in research only. This study aims at addressing the following 3 questions. This work aimed at systematically reviewing the use of grid literature in software engineering and exploring software engineering researchers' views on grid literature. The aim of this study is to help improve the use of grid literature in software engineering research by empirically obtaining and synthesizing the relevant information from the views as well as survey sources. We avoid to criticize the reviewed studies or their others by all means. Because second studies can better reflect the 5 concerns of grid literature: the scope, the search, the analysis, the evaluation, and the experts. We selected secondary studies for this research that were accepted to help synthesize the current studies of the use of grid literature in software engineering. After trials, we found its difficulty to formulate a reasonable search string to effectively cover as many primary studies, including grid literature, in software engineering as possible. Healthy, we did not consider primary studies with grid literature at this stage. We designed 2 questionnaires respectively for these grid literature users and the software engineering experts. The software engineering experts' response to these questions purport not only to enable us to understand the respondents' views on the use of grid literature, but also to provide useful suggestions for using grid literature in software engineering. The grid literature users' response to these questions could enhance our understanding of how they use the grid literature in their research. We identified 102 secondary reviews included grid literature in software engineering that were published by June 2019. The picture shows the distribution of these included reviews over years, and the short-term arrows indicate the reviews reporting rich details of the use of grid literature in recently. The growing trend of the reviews in software engineering incorporating grid literature tends to be significant. In particular, there are 72 reviews published after 2014, which is more than twice before 2014. It indicates that software engineering researchers have been increasingly realizing the leveraging the potential view of the grid literature. The different perspectives of software engineering researchers on grid literature can be reflected to 3 major dimensions: the accessibility, the quality control, and the express. Accessibility refers to whether the content is widely available. The quality control depends on who provides the content. The expertise focuses on the authority of the content producers. It's noticed that software engineering researchers considered including grid literature mainly because they are intent to avoid publication barriers, seek more related research, explore unchecked error in software engineering, compare different perspectives between researchers and practitioners, understand views of the practitioners community. For seek more related research, original but field research may also be interesting for researchers who want to try a new method. They should want to know what other people have already tried, which is seldom published. For explore unchecked errors in software engineering, grid literature can also be used to verify the results of academic literature, to know if there exists any gap between the information coming from literature and industry. The probable use of grid literature can help bridge the gap between the significant studies and the practice and views from industry. Combining expert opinions with our reviews, we proposed a conceptual model for how grid literature works in the software engineering research lifecycle. The conceptual model includes 5 perhaps: generating idea, searching grid literature, evaluating grid literature, using grid literature, and reporting findings. In general, grid literature can help researchers develop new ideas, identify new research questions, and discover new findings. The difficulty of evaluating grid literature leads to the real evaluation of grid literature in software engineering. One grid literature user indicates that during their studies on pair programming, they are willing to evaluate grid literature, but had no specific quality assessment framework. While list, our findings may raise the awareness about the current state of the use of grid literature in software engineering. Our effort also contributes to the methodological improvement in empirical software engineering. We also discuss some major challenges associated with using grid literature in software engineering research. Thinking about these challenges also help software engineering researchers to make decisions on the use of grid literature. We plan to conduct future research based on data from the grid literature for gaining deeper insights into, as well as improvement for the use of grid literature in software engineering research. The lack of systematic guidance for conducting grid literature research leads to the healthy state of its use in software engineering. To provide a framework for assessing grid literature in software engineering and a clear set of recommendations for using grid literature in software engineering, the next steps we need to focus on. Thanks for listening.
Okay, thank you, Jin, for that very interesting presentation. And we do have time for a few questions. And I think there is one very interesting question posted by Steffen Herbold. And he's asking how reproducibility of searches for grid literature is handled. Because for white literature, you have search engines, you have digital libraries, but for a grid literature, you might use Google to search for those. And those search results might change.
Pardon?
So I think his question is how, or is there a way to make sure that the search results are reproducibility? If you conduct multiple searches, that you get the same search results for gray literature and not get completely different results.
Indeed, as you said, gray literature may also have informal peer reviews like white literature. So how to evaluate the quality of gray literature is more important than determining what is gray literature. That's exactly what we have been doing recently.
Okay, I think we're running a bit out of time here, but there are a lot of additional interesting questions in the chat. So if you want to check the chat, I think you can answer a few more there. So that's thanks, Shin, again for this very interesting talk, and let's proceed to the next speaker then. Thank you.
Okay, thank you.
And the next paper in this session is going to be the first journal-based paper, one of 4 papers in that session, as I said in the beginning, and it's from the Transactions of Software Engineering, and THC from the University of Hong Kong will talk about metamorphic robustness testing in the context of citation statistics. So please, TH, the stage is yours.
Well, we're going to present our work on metamorphic robustness testing, which exposes some very surprising defects in citation statistics and journal impact factors. How do I? Okay, this is a journal first presentation for an article published in IEEE Transactions on Software Engineering. We are asked to compress our 20-page paper into 6 minutes, so we can only concentrate on some of the more interesting aspects. First of all, let me give you some background. A test oracle is the mechanism to check whether the execution result of the software agrees with the expected outcome. We say that there is a test oracle problem if the oracle is not available in real life. Let me take Google search engine as an example. Suppose we want to do keyword search for hotels near JP Morgan. So after searching, we obtain 5 million results. Because of the big data, we are not so sure whether 5 million results is too many or too few. This will be an oracle problem. So in metamorphic testing, we alleviated the oracle problem by verifying the consistency between multiple execution instead of single execution. This is known as metamorphic relation. Take the Google search as an example. Possible metamorphic relation is to refine the keyword search. And if we refine the keyword search, we should obtain fewer results, right? So we refine to hotels near the full name JP Morgan Chase. So given the full name, we should obtain fewer results. But in fact, we obtain 6 million entries, which is 1 million more than the original inquiry. This indicates a failure in the Google search engine. So we apply the metamorphic testing concept and have a new application in robustness testing. We want to verify whether a system can deal with erroneous inputs. For example, can Web of Science handle citations with a typo in a hyphen inside the paper title? So this is a very, very small typo, and yet can Web of Science handle this? This is another test oracle problem because of the big data. So we introduced the concept of metamorphic robustness testing. We define metamorphic relations to test the consistency between multiple retrievals instead of single retrievals in the citation index system. Let me give you one simple example. Given large sets of publications without systematic differences, their citation counts should also have little systematic differences. Indeed, suppose we are given 8 sets of or 9 sets of publications, each with a different number of hyphens in the paper titles. The mean citation per paper should be very similar. Unfortunately, in Web of Science, the actual result shows that given the more number of hyphens in the paper title, the mean citation counts per paper would be reduced. This is completely surprising. So it shows a robustness failure in the Web of Science index system. We have done further findings. We have discovered further failures in citation counts and impact factors at the article, journal, and subject levels. Unfortunately, Michael has only given me 6 minutes of presentation time, so I will have to ask you, please read the original paper. In conclusion, our result questions the belief that citation counts and journal impact factors are reliable quality measures. Every day, these factors would affect our promotion prospect and our tenure prospect. But then these same factors are distorted simply by some minor errors in the hyphens in the paper titles. So our paper has been recognized. Our so-called bizarre finding was reported by numerous international media on top of IEEE TSE, such as in Nature, Communications of ACM, Psychology Today, the Australian, Science Alert, and Wikipedia. But not everybody was amused. The original vendor, Web of Science, published a strongly worded rebuttal. They say that hyphens in article titles have no impact whatsoever on citation counts.
30 seconds.
They emphasize that their methodology has been tried and tested over many years. We want to have a final observation within these 30 seconds. This exactly demonstrates the significance of our new approach in discovering robustness defects that were never discovered in previous tests over many, many years. So your comments are welcome. Thank you.
Great. Thank you, TH, for this very interesting presentation. Do we have any questions? Not yet. I actually do have a question, a quick one. In the paper, you mentioned that you mainly focused on hyphens. Do you think besides hyphens, there are other issues in citation engines? For example, I could think if someone has two first names or other kinds of things that would be a problem for being correctly cited. Have you any insights on that?
Yes, in fact, we have done various studies on various possibilities, but we purposely chosen hyphens because this is the most surprising. It has nothing to do with the quality of the paper. So for things like spelling errors and this kind of thing, they may affect the quality of the paper, but the presence of a hyphen has absolutely nothing to do with the quality of the paper, and yet it will affect our promotion and tenure.
Okay, thank you. So there is another question by Alexander. So basically the takeaway message is for authors that they should avoid hyphens in paper titles to actually get cited more.
This was not the original intention, but I guess from now on, people will have fewer and fewer hyphens in their paper titles.
Okay, I think we have to switch to the next paper.
Thank you.
Thank you again, TH, for this really interesting talk and the interesting questions that stem from that talk. And let's move on to the next paper. And we have another journal first paper, again from TSE. And Sierra will be talking about procedures and guidelines for software engineering replications. So please, Sierra, go ahead.
Thank you very much. 1 second, I am going to check where I am. Okay, so experiments in software engineering are commonplace. In order to increase the reliability and generalizability of experiment results, software engineering researchers build groups of experiments by means of replications. According to a systematic mapping study that we performed, 5 techniques are used to aggregate the results of software engineering experiments. However, according to the literature of mature disciplines like medicine and pharmacology, they suggest that different techniques might be more suitable than others. So the aim of this research is to answer the research question, how should groups of software engineering replications be aggregated? To answer this question, we perform a literature review on mature experimental disciplines like medicine and pharmacology to learn about the techniques that they apply to aggregate the results of their replications. However, during this literature review, we noticed that there were differences between groups of replications in software engineering and in medicine. More precisely, in multi-center controlled trials, the experimental configuration is identical, the selection criteria is rigid and random, and sample size is balanced and appropriate. However, in groups of software engineering replications, there are opportunistic changes, convenient sampling is used, and sample size is unbalanced and small. This leads us to a second literature review of studies with similar circumstances to those in the software software engineering within the fields of medicine, social research, education, research, and econometrics. In view of the results, we propose a procedure to facilitate the aggregation of results in groups of software engineering replications. It consists of 4 steps. First, participants are described. Then individual replications are analyzed. Later, results are aggregated. And finally, exploratory analyses are conducted. To illustrate this procedure, we will analyze a group of 4 replications that investigate the external quality of 2 different development approaches, ITL and TDD. The 4 replications that we analyze share a common A-B repeated measures design. So let us explain the procedure. The goal of the first step is to describe the population to which the results should be generalized and suggest possible sources of heterogeneity for joint conclusions. So when checking in our example summary statistics, we cannot observe any specific pattern across different experiments as regards programming, Java, unit testing, and JUnit experience. However, when checking profile plots, you can see that participants show a higher programming and Java experience, compared with unit testing and JUnit. Additionally, we can see that there seems to be a heterogeneous group of participants across the different experiments. The goal of the second step is to identify patterns across replication results and ensure that statistical heterogeneity is not introduced by the individual analysis. So the summary statistics here show that TDD outperforms ITL. However, the difference in performance varies between the different experiments. The profile plot confirms the previous results. And finally, the individual analysis show that not all observed differences are statistically significant. The goal of the third step is to increase the reliability of joint conclusions by applying AD and IPDS in tandem. AD shows that TDD outperforms ITL in our example. However, and also we can see that the joint effect size is large and statistically significant. However, there seems to be some heterogeneity, which means that moderator variables should be explored in a later step. IPDS confirms the previous results and also shows us that TDD performs double better than ITL. The goal of the fourth and last step is to identify moderators that may be behind statistical heterogeneity. First, we are going to assess the impact of the subject type on the results of the experiments. So we are going to assess the differences between students and professionals. Our results show that students benefits more from TDD compared to professionals. However, neither AD nor IPDS are able to detect the effect, meaning that more experiments are needed. Next, we are going to check or assess the influence of the different participant level moderators in the results. We can see that the experience in programming, Java, unit testing, and the unit of participants shows an increase in the performance of TDD.
1 minute.
Okay. However, it is important to acknowledge that these exploratory analyses have three limitations. The first one is that we cannot observe cause-effect relationships with them. Additionally, the likelihood of committing a type 1 error is increased. And finally, if there are multiple changes among the different replications that we run, the effects of the variables can be confounded. So thank you very much for your attention. I will be very pleased to answer any questions.
Okay, thank you, Sira, for this really interesting talk. Are we having any questions? If you have a question, please post it now on Slido so that I can ask it to Sira. Okay, I do have a question. When I was checking the DXY program, I couldn't actually find a lot of replication studies. I actually could hardly find any. Do you think they're still underrepresented? And do you have any idea why that's the case?
Yes, in fact, a few years back, there was a mapping study on the status of software engineering replication, and the authors of that mapping study was Fabio da Silva and collaborators. They found that each study was replicated an average of 1.8 or something like that times. So in the software engineering community, we think that the reason for this could be that it is very difficult to replicate experiments, and also they are very hard to publish. So that's the reason why people typically do not tend to like running, let's say, replications. But yeah, so there's still a lot of work to do within the replications, software engineering replications field. We have a lot of work still to do so that people can learn how to do them, how to properly run them, what are the differences that, I mean, how much they can change the experiments between different replications. So yes, there's a lot to do, and especially make people to be aware how important replications are.
Okay, thank you. There's another very quick question, if you have a quick answer for that, from Steffen Herbold. And And since one of the next papers is talking about Bayesian statistics, would that make a difference? He's asking if you use Bayesian statistics for the studies.
Sorry, can you repeat the question? The difference?
Would Bayesian make a difference, was his question. I think he's probably referring to the results or findings from one of the studies you were looking at. Mm-hmm. Maybe you need to discuss that offline, and he can clarify what he meant with that question.
Okay, yeah.
Okay, thanks again for the talk. Since we're running a bit of time again, let's switch to the next paper. And that's going to be a very brief tool demo. And Andreas is presenting an SLR tool for search and process in practice. And we're going to play that video.
Hello everybody and welcome to the presentation of our SLR tool. This tool helps you to manage your systematic literature review and is based on the publication of Barbara Kitchenham. The SLR tool focuses on the life cycle of the SLR process. For this purpose, the SLR tool empowers you to manage, to organize, and to qualify the search results from the search engine. I will show you the SLR tool in detail in the next 2 minutes. The process starts by creating a new project. Here you can type the name of the project, the search string you use, and a comment. At this point, the project is created. The next step is to import the search results from the search engine. Like Springer Link, Web of Science, and so on. I exported the search result in a BibTeX format. In the SLR tool, I add a new import file and insert the search result. After this, I can import the search result by clicking on the import button. Now the SLR tool imports the file and check whether there are duplicated entries. Back to the project, you can see all the imported papers. Every paper is listed with its title, keyword, authors, journal, and so on. You can use the function update from Crossref. This function adds missing abstract of the paper, updates the format of the authors, for example. At this point, you can open the paper by clicking on the DOI link, the digital object identifier. This opens the paper directly from the digital library. Another way is to open the paper is the Open Paper button. This opens the paper within the SLR tool. It shows all the necessary information you need. Now we have a complete list of papers for the SLR. At the top of the list, you can see tiles with the different numbers of papers. This represents the status of the papers. The idea behind this is to represent the lifecycle status of the papers in summary. You can set the status of the paper by clicking on the button Include by the tiles, Exclude, or No Access. The paper moves from one status to the next status. And the last status is after scan content. This means that the paper will be included in the SLR. In this presentation, I have presented our SLR tool to manage the life cycle of your SLR and support you in conducting the SLR. We hope you enjoyed the presentation and the SLR tool is available for your SLR.
Okay, thank you, Andreas. For the presentation. Unfortunately, for the tool demo, we don't have time for additional questions here. However, Andreas is going to have a live session today at 9 UTC, where I'm sure he's happy to answer all the questions and give you a more in-depth view of the tool itself. So again, thank you, Andreas, and all the authors for the tool demo. And as time proceeds, we are moving on to the next paper. And the next paper is going to be a new ideas paper. And Yu Yong Chon from the Handong Global University is talking about threat to validity in experimenting mutation-based fault localization. So please go ahead with the presentation, Yu Yong.
Okay. So can I start my talk? Okay. So hi, this is Juyong John, and I will start my talk. The Defects4j benchmark give great chances to evaluate the testing technique reliably by providing a modified real-world bug cases. As large number of bugs are gathered from the open source projects without modifications, it enables us to conduct a quantitative analysis in a more fair manner. One result with Defects4j is to compare the fault localization techniques, and the results of that study implies that the MBFL techniques do not perform well for the faults in Defects4j, which was contradictory to the study results of the MBFL techniques. Here we have a question about the exact reason why MBFL fails to show high performance in Defects4j, because we wanted to find a way to improve the MBFL techniques. But we could not get the answer from the original study because it only shows the quantitative results. So we have revisited the same experiment, rather focusing on the qualitative analysis. As a result, we have found that when evaluating the MBFL techniques, the configurations of the experiment setup largely affects the result of the evaluation, so these should be carefully managed. So now on, I will present more details about my research. So as the first step, let me quickly explain what mutation-based fault localization, or MBFL techniques are. MBFL locates the buggy lines by observing the changes in test results after the target program is mutated. So the effectiveness of MBFL depends on the information obtained from the test results of mutant executions. In this study, we revisited the ICSI 2017 study, but with a different configuration. We had revisited all of J-free chart artifacts and checked how the results changed. To alternate the configurations, we removed the noises in bug artifacts and used as much resource as we are given by assuming a human debugger who is localizing the faults is putting her best effort. We removed the noises in bug artifacts in two ways. So first, we refined the buggy lines as the locations of a single bug and employed test cases only if they are relevant to the bug. Although the Defects4j artifacts contain multiple bugs, the evaluation is determined by one most suspicious line of a bug. We have suspected that this might be unfair. Second, we filtered out the flecky test cases, and we ended up removing the two artifacts that do not reproduce the specified failures. The next configurations are based on the best effort debugger assumption, and the best effort debugger will use as much mutant execution information as possible. So we first used all possible mutation operator given by the Java mutation tool, the major. Then we chose as many possible passing test cases by selecting every test case that covers at least one line that executed by a failing test case.
1 minute.
Another setting is trying as much investigation with given failing test cases as possible. So we also purified the failing test cases, which will help MBFL observe the test results changes more clearly. Finally, we excluded the surely safe lines from the ranking, and this was done because the MBFL techniques may assign a negative score to the suspicious lines. So this is the result, and we saw that results of the experiment changed sensitively by the configuration. And among the 26 artifacts, the comparison result of the fault localization techniques changed in 19 bug artifacts. These are some of the selected cases where the evaluation results dramatically changed, and we found that all the configuration change matter to the evaluation changes. So finally, our study shows the various factors that matter largely on the MBFL evaluation results. So these needs to be carefully managed in the experiments. There needs to be more qualitative analysis on the Defects4j artifacts for the improvement of the benchmark. And this is the end of the talk, and thank you for your attention.
Okay, let's thank you, Young, for a very interesting presentation. And do we have any questions? I do have a very quick question since it's a new ideas and emerging research paper. Could you talk a bit about your plans for the future? What would be the next step in your research, and what are you planning to do next?
We are planning on looking on the more artifacts, since we only looked into the J-free chart artifacts. We're planning on looking on the other open source projects in the DepEx4J.
Okay, thank you. And there is another question which was just popping up, a very quick answer. Does your artifact include all the existing D4J faults?
Of course not, no. No. Oh, only the J-free chart artifacts.
Okay. Okay, I think we need to move on to the next presentation. Thanks again, Yu Young, for this really interesting talk. And moving on to the next paper, which is again another journal first paper. And Alessandro is talking about performance evaluation in cloud computing. Please, Alessandro.
Hello, everyone. My name is Alessandro, and I'm presenting our study on methodological principles for reproducibility in cloud performance evaluation. So I want to start with the situation that we will experience at least once in our academic career. Let's say that you find a very interesting paper with great experimental results, and you would like to reproduce the same results, for example, to compare with your own research. But when you try, you realize that you can't reproduce the same results, either because you don't get the same numbers as the one presented in the papers, or because you have no idea how to replicate them. This can be due to several reasons. For example, the code or the data sets or the infrastructure used in the paper are not publicly available. Another case is that the paper does not fully report the experimental results or the experimental setup. And in general, this can be a very, very common problem in science. And it shaped, in a way, this type of problem, the research methodologies of several research disciplines, such as physics, biology, or medicine. The problem of reproducibility is even more complex in the context of cloud computing. For example, if we run an application twice under different conditions, this may produce significantly different results. And this may be due to hardware or software updates on the cloud infrastructure, or to the current load on the data center, or several other reasons. In general, reproducibility in cloud computing systems is extremely important, not only because it is at the basis of the scientific method, but also because there is a risk that products and services in the market behave differently than advertised, or they can even crash. And this can have a huge impact on the credibility of the cloud computing field. So we started discussing the idea of reproducibility in cloud computing within the SPEC research group, and we soon realized that providing a unique definition of reproducibility in this context is extremely challenging. We then decided to focus our attention on the definition of the methodological principles that enable reproducible results in cloud computing. We formulated 3 research questions that guided the research. First, what is the basic set of methodological principles required for conducting a sound experimental evaluation in cloud systems? And this, in our opinion, is extremely important, and should, in general, reproducibility in cloud systems should be driven by a reasonable protocol or by a set of guidelines that need to be defined. Second, can such principles be applied in practice? And finally, how are cloud performance results obtained and reported currently in the scientific literature? So let's proceed in order with these 3 research questions, and let's see how we responded to all this. So the first question relates to the methodological principles. And in this study, we propose 8 principles that cover the basics for reproducibility in cloud computing. P1 and P2 are conceived to capture the variability of the obtained performance through a suitable experimental design. P3 and P4, on the other hand, are related to the availability of the tools used to produce the experimental results. P5 to P7 are related to the information required to properly report the obtained results. And finally, P8 relates to the additional information, such as the cost model adopted for the experiments. This responds in a way to our first research question. However, this list is not meant to be complete. It is hard to say that these are the only principles required. Several additional principles can be added to this list. However, when we try to add new ones, they were either special cases of the proposed ones or application specific, and we wanted to be a bit more general. Future work will be devoted to extend these principles. Going to the second research question, we apply the proposed principles to a representative showcase in cloud computing, that is the performance evaluation of an auto-scaling application. We conducted the experiments and reported the results according to the given principles, and we include also a discussion on how to interpret the obtained results. And what is interesting is that it took less than 2 pages to fully describe the application, the results, and their statistical analysis. And this responds in a way to our second research question, that is, can we apply this in our research? Can we apply this in practice? And the answer is clearly yes. And finally, we investigated to what extent the proposed principles are applied in already published scientific papers. So we selected some of the main cloud computing venues, including both conferences and journals. We analyzed only the papers published in the last 5 years at the time when we started the study. And we were interested only in papers that contained experimental results, so no simulations or very tiny experimental setup. After setting such selection criteria, we adopted a systematic literature review approach to analyze the published papers, involving 2 reviewers per paper in charge of identifying relevant papers matching the selection criteria and of analyzing the identified principles if they were present in the paper or not. The process included also an open discussion phase to consolidate the opinion of the reviewers in case they were disagreeing. So a summary of the obtained results are reported in this bar charts. The 2 reviewers are indicated with the blue and red bar. The x-axis indicates if the principle is present, indicated with Y, partially present with P, or not present with an N. And the y-axis indicates the percentage of the analyzed papers. So the highlighted principles, they show practically that more than 50% of the analyzed papers do not apply the principles, the considered principles. And this is true for 5 out of 8 of the proposed principles. And only for for principles 3 and 7, which are fairly simple, this is not the case. However, P3 and P7 just require the description of the experimental setup and the presence of the measurement units when required. And the fact that we don't have a full yes here, it's a bit of a warning signal. So concluding, in this work, we presented a set of 8 principles for improving the performance evaluation in cloud computing. We showed how such principles can be applied in practice on an application in cloud computing. And finally, we showed that the published scientific literature is not extensively applying the proposed principles. In the future, we will investigate a possible extension of the proposed principles, possibly covering domain-specific applications. And in general, the take-home message is that we should reflect a bit as a research community on what are the potential actions that we can take to improve the reproducibility of our research. And I want to conclude that making cloud results accessible and reproducible to the research community is an important aspect for growing and advancing science. So I thank you all for the attention, and I'm really happy to take any questions.
Okay, thank you, Alessandro, for this really interesting talk. Do we have any questions for Alessandro? In fact, there is just one that came up from someone who didn't tell us his name, but that person is asking whether there is some kind of checklist of things that someone would expect to see in such a paper. Is there anything out there?
Yeah, I mean, there is actually Sigmod that created a checklist of some of the main things that should be included in the experimental evaluation and in the presentation of the results. We found out about this while conducting this study, but then there is some overlap, but it's not a huge overlap because, I mean, it is more like a very basic checklist to give to the authors. And it's not really on the cloud computing community, so we want to, in a way, replicate a similar initiative in the cloud community.
Okay, thank you. And another very quick question. Which of those principles you hadn't mentioned in your paper do you think is the most challenging one for reproduction of the experiment?
I guess the statistical evaluation in terms of not only repeated experiments, but also in a way the coverage of what can happen in a way. That is the most challenging part, because you have not full control of the experimental setup and the experimental the hardware practically that is running everything. So that's I believe the most challenging part.
Okay, then thanks again, Alessandro, for the talk, and let's move on to the next presenter. And the final paper in this session is going to be presented by Carlo, and he's going to talk about in another Journal First paper about Bayesian data analysis in empirical software engineering research. So please, Carlo, go ahead with your presentation.
All right, I think the screen sharing is working. Okay, so thanks for the introduction. This is a very short summary of the TSC paper that I wrote with my colleagues Robert Feld and Richard Torker. And this work is really about different approaches to statistical analysis. And in particular, it's common to compare to different schools, so to speak, of statistical techniques, frequency statistics versus Bayesian statistics. Frequency statistics include widely used techniques such as null hypothesis statistical testing and confidence intervals. And Bayesian statistics, on the other hand, is ultimately built on the famous Bayes theorem of conditional probabilities. Besides providing two alternative sets of techniques, frequencies and Bayesian statistics differ significantly in the kind of analysis and procedures that they support. So as illustrated quite well by this SKCD comic, frequency statistics is primarily concerned with rigid procedures and mathematical rigor. Bayesian statistics, in contrast, has a more pragmatic approach, if you want, and this pragmatism can really make a difference in how practically useful a statistical analysis can be in the end. In recent years, we have seen an increasing criticism of frequency statistics, and in particular of practices such as null hypothesis statistical testing. And ultimately, this criticism has culminated in some calls made by a number of scientists, including some very prominent statisticians, that we should stop using altogether null hypothesis statistical testing as a basis for statistical analysis in science. For those of us who have been doing empirical data analysis in the context of software engineering, I thought that it's a very good time to learn about the issues that have been highlighted about frequency statistics, and also to learn what kind of advantages switching to Bayesian statistics as an alternative may bring. And this is what this talk and the related paper is really primarily about. So to give a short overview among all frequency techniques, I'm going to focus on null hypothesis statistical testing once again, because it's so widely used and suffers from a number of well-known issues. So to demonstrate these issues in the paper, we go through some data comparing the performance of different programming languages based on Rosetta Code repository. And this data was originally analyzed in a related publication independent of this particular study, using techniques from null hypothesis statistical testing. So in this context, using this kind of frequency techniques, so if you want to compare the performance of two programming languages, let's say, for example, that we want to compare C to Python, then we should formulate a null hypothesis. And typically, the null hypothesis encodes the scenario where there is no difference or no statistically significant difference between, in this case, the performance of C and Python. And then using the machinery of null hypothesis statistical testings, we would compute a statistic called the p-value from the data. And the p-value is a probability. And if this probability is small, typically below 5% or even smaller, then we conclude that the null hypothesis is unlikely to hold. And so we reject it. Otherwise, we fail to reject it or we don't reject it. To be a bit more precise, the p-value is a conditional probability. So it's the probability that the observed data would occur if the null hypothesis were true. So if p is small, is very small, then it means the data is unlikely to occur under the null hypothesis. But one of the key problems with this approach is that p-values are perfectly well defined mathematically, but they do not quite capture what we really want to know of an experiment. Because The p-value is the probability of the data, assuming the null hypothesis, but what we really want to know is the converse probability, the probability of the null hypothesis given the data. And in general, we cannot get from one probability to the other without additional information. So Bayesian statistics is an alternative approach, but it's not just a patch of frequentist techniques. It's a whole new look at the process of statistical analysis, which is quite different. Bayesian analysis, first of all, emphasizes modeling of our assumptions and of the relations between data. The interpretation of Bayesian models typically correspond more closely to the intuitive notion of probability that we have. And Bayesian models also naturally incorporate domain knowledge and assumption in a quantitative, transparent way. So this slide shows, in very briefly in a nutshell, the basic ingredients of a statistical analysis based on Bayesian statistics. Models are ultimately based on probability distributions of some quantities of interest in the domain of analysis. So if we go back to our running example, which we also reanalyze in the paper, if you want to compare the performance of C and Python, then we could, for example, build a probability distribution of speedups of one language over the other. And then the input to the Bayesian analysis includes, of course, the data, but also prior distribution, which is essentially a formalization of our domain knowledge and of any assumptions that we want to use. And then the output of the analysis is also full distribution instead of just a scalar statistics like the p-value is, which we can analyze in detail to answer all sorts of questions we may have about our data in a quantitative and principled way. So naturally, this was just a short teaser of the main message in the paper. That is that Bayesian statistics can be a natural and powerful alternative to frequentist techniques, and they can help your statistical analysis become not just formally correct, but also more practically useful. So if any of this is interesting to you, of course, please make sure to check out the TSC paper, as well as other papers that Robert, Richard, and I have been working on for many more details.
Okay, thank you, Carlo, again for this really interesting talk. Do we have any questions for Carlo? And I see one from Steffen, and he's asking, how often would you guess we would get different results with Bayesian statistics instead of the correct NHST? Do you have?
That's a good question, and I think it's hard to give a clear-cut answer. I would say not many cases, provided, as Stefan remarked in the question, that frequentist statistics are applied correctly. So using Bayesian statistics is not primarily about getting different results, but I would say it's more about having a more principled approach and an approach that connects more easily with practice. So there are many advantages, and I don't think getting radically different results is something that you would necessarily encounter often.
Okay, thank you. And there is another question from Alexander, and he's asking whether you did derive a different conclusion by using Bayesian statistics about the C and Python as opposed to the null hypothesis testing.
Mm-hmm. Yes, so I don't remember specifically about C and Python, probably no for C and Python, but the data was not just about C and Python. We compared several different programming languages pairwise, and we got some subtle differences with the Bayesian analysis. It was not a radically different picture, but we could clarify a few dark corners a little bit better. So, and of course, the details are in the paper.
Okay, thank you. And we have another question with a very quick answer, I hope, from Gopi Krishnan. Is it easy to get the prior distributions in cases where the analysis is primarily exploratory?
Yes, so getting the prior is not a big deal. It's something that when you first approach Bayesian statistics, you think it's something that is problematic, it's delicate, and so on. But really, you don't really pick the prior. You typically try out a variety of different priors, and this is also a sort of like what if analysis gives you. But you can almost always find some priors that are very that don't introduce any significant bias, and they're kind of like safe generic choices. And if you want, you can also try out something else. But normally it's not an issue. It's just a matter of becoming familiar with the practices of this kind of analysis.
Okay, thanks again, Carlo, for this really interesting talk. And I think we are out of time. If you have additional questions to Carlo or to any of the other authors, I think they're happy if you just shoot them an email or contact them via Slack or via the Crowder app, so that they can answer additional questions you have, which we aren't able to answer during this very brief Q&A sessions for the papers. And again, before we conclude the session, let me remind you of the tool demo live session Andreas is having in the afternoon at 9 UTC today. And I think that concludes the session. Thanks to all the presenters for the great talks, and thank you to all the participants for asking all those great and interesting questions. Thank you.
Thank you.
This is Chanchal Roy from University of Saskatchewan. I will be chairing this exciting session on clones and changes. We have several exciting talks, both on clones and changes. Some of them are state of the art, and I hope you will enjoy the session. So our first presenter for this session, or the first exciting talk, is on HARP, which is called a holistic analysis for refactoring Python-based analytics program. And that will be presented by Weizhi Zhao from North Carolina State University. So Weizhi Zhao, could you please start for your presentation?
Sure, let's share the screen. Let's see. Okay, let's start. Welcome everyone. Thanks for attending my talk. I'm Weijie Zhou, a PhD student from NC State. The work I'm going to present focuses on the optimization of Python-based analytics programs, which we call HARP. So the work is a collaboration with Yue Zhao, who is working at Facebook now, and Guoqiang Zhang and Professor Xipeng Shen from NC State as well. These days, Python becomes the most popular programming language in machine learning domain. A common pattern in today's analytics ecosystem is Python plus X, where X represents the core computation written with APIs of these libraries such as TensorFlow, PyTorch, and so on. And Python is regarded as the glue language that connects all these pieces together. So let's take TensorFlow as an example. Suppose we want to do the computation showing the right side in TensorFlow. From the corresponding code, we can see the whole program is written in Python. And when we run the program, it will first call the TensorFlow APIs to construct the computation graph. Then the computation graph will be sent to and executed by the TensorFlow backend by calling the TensorFlow.session.run API. This programming model represents an important category of machine learning frameworks. So to optimize this kind of program, there exists a lot of works focusing on the computation graph optimization. But the problem is they ignore the information from the host code and the interplay between the host code and the backend. Therefore, they will miss some optimization opportunities. The problem we address is to optimize the Python plus X programming model with a holistic view. The result is a framework we call HARP. The core of HARP is an automatic static code optimizer with a holistic view, which bridges semantics from host and the computation graph. And it also provides a refactoring assistant that provides suggestions for developers. So our methodology consists of following steps. First, given a target program, the HARP compiler will first extract semantics from both host program and the computation graph. Then these semantics are synthesized into a unified knowledge base called augmented graph. It is represented in Datalog, which is a declarative logic programming language. Analysis algorithms are written as query rules. HARP engine will perform these rules on the knowledge base and gets the result. There are many challenges when we build HARP. First is Python language complexities due to the dynamic feature. As a dynamic programming language, Python poses many difficulties to the static analysis. Based on our statistic, and analyzable language capacities are rare in analytics programs. For those capacities that do matter, they can be treated through speculations. Second, the needs for uniform analyzable representation. So for holistic analysis, it is preferred that needed information of the program is represented in an analyzable form. As I just mentioned, we synthesize the semantics from both sets into the augmented graphs upon data log. So with all these semantics represented uniformly in the data log syntax, we can easily write the logical rules in data log to infer new knowledge about the augmented graph. So last, we also provide a conditional feedback mechanism for needs for the risk controlled feedback, which I will show it in detail later. So here is an example. The code is which we showed before. We can use this example to see why HARP works. From the code, we can see that D and X are assigned from the host code. If we suppose D is constant, then the intermediate computation, T2, is loop invariant because T2 represents D times D transpose. So however, since the assignment of D is outside the computation graph, the TensorFlow backend is unaware of this constant semantic. Therefore, it misses the opportunity to remove the computation redundancy. With HARP holistic view, we can find this redundancy and eliminate it based on the host program semantics. So in addition, to control the risk of uncertainties in the analysis, we provide an refactoring assistant for user to resolve the uncertainty. It not only provides the refactoring suggestions, but also the explanation and the assumption it holds in its speculations. We conduct both the efficiency evaluation and the usability user study. The results shows that HARP guidance leads to significant speed up on a set of benchmarks, and around 12 graduate students are asked to optimize the benchmarks, and HARP shows that it can increase their successful rate in refactoring the programs. So here are the conclusions. HARP enables a holistic analysis that spans across computation graph and their hosting Python code. The methodology that we use is analytics conscious speculative analysis for Python language complexity, and unified representation for holistic information, the conditioned feedback for risk control. For the evaluation, refactoring based on HARP gives 1.3 to 3 times speed up, and around 2 times average speed up on set of TensorFlow and PyTorch programs. So that's all for the talk, and I'm glad to
Thank you, Uzi Zhao.
Mm-hmm.
So, like for your user study,
mm-hmm.
So how many users were there? I mean, and how did you conduct the user study? Did you have kind of scenario that they have to process this, like, and what did they feel?
There are a total of 12 graduate students participating in our user study, and these students are from our compiler classes. And some of them have some basic knowledge about the Python, and some of them, I think almost all of them has basic knowledge about Python, and half of them have the knowledge about the TensorFlow and PyTorch. Yeah.
But then, what kind of like tasks did you ask, and did they have data analytics or analytics knowledge, or like?
We totally gave them full inefficient programs, focusing on the TensorFlow and PyTorch, then we first will ask them to optimize these kind of knowledge problems by themselves and give us the feedback. Then we let them to use our HARP tool and also answer the same questions about the refactoring time and whether or not they optimize the improve the programs. Yeah.
Okay. And it's when actually, I mean, did you have any kind of group? Because if you give them already the problem and they know about the problem already, maybe the next time when whatever tool they use, they might be able to do it better. So sometimes people do it, okay, make two groups. First you give them the tool, and then second you give them without tool, and then other way around. So what happens, does it differ like for both of the sets?
Yes, I think that's a good idea, but in reality, there is some problems because the optimization mainly based on their background of the TensorFlow machine learning knowledge. But we cannot make sure these two groups have the same knowledge base.
And also, like, did you have any expert people that evaluate your approach or no? Like you said, all are kind of student, but is there anyone like who is actually doing a lot of those things, expert in the domain?
No, I think most of them are trying to. Most of them are learning the machine learning frameworks from their first round optimization works.
Okay,
yeah.
Thank you so much. Yeah, thanks. It was a great talk and very interesting. And we are going to go for the next exciting talk. That's also a technical paper, and that is on like distributed representation of code changes, and which is called CC2VEC, and that will be presented by James Thong from Singapore Management University. So James Thong, please go ahead.
Hello, can you hear me? Hello, everyone. I'm happy to be here to present my work. It is a collaboration between Singapore Management University and the Inter Institute. The goal of our paper is that we want to build a vector representation of a code changes and apply it to many software engineering problems. The first question is, what is code change? The code change is in commit, and the commit normally has two types of information, a log message and a code change. The log message gives you information about the change in a human language, while the code change include the remove the code and the edit code. So why the code change is important? The code change is important since it can be used to solve many software engineering problems, such as efficient batch identifications, just-in-time defect predictions, code review recommendations, and maybe many more. However, there's some limitation from the previous work related to code change. First, these prior approaches only focus on a specific software engineering task, such as just-in-time defect predictions, bug fixing batch classifications, and so on. Second, all the information in the code change, the number of code tokens, the number of lines, the number of hunk, are treated equally. Moreover, the previous work also ignored the difference between the removed code and the edit code in the code change. To address these limitations, we propose a CC2VEC, a deep learning model that can produce an embedding vector of a code change. The vector can be used to improve the performance of the software engineering application related to code change. The CC2VEC takes advantage of the attention mechanism, and all the information in the code change is treated differently. Moreover, the CC2VEC also consider the difference between the removed code and the added code. Here is the overall framework of our CC2VEC. The feature extraction layer are used to construct the embedding vectors for each file from a given code change. The embedding vectors are then concatenated to build a vector representation for the code change in the commit. And the code chain is connected to the fully connected layer and is learned by minimizing an objective function of the word prediction layer. The key component in our framework is the hierarchical attention network used to extract the features from each file in the code change. The next is the input of the feature extraction layers is the remove code and the edit code of each file in a given code change. The remove code is the three-dimensional matrix indicating the number of hunks, the number of lines, the number of code tokens. So in this case, we can preserve the structure of the remove code. In a similar ways, we also use the three-dimensional matrix to represent the edit code. Our hierarchical attention network includes a work sequence encoder, a work level attention layer, a line encoder, a line level attention layer, a hung sequence encoder, and a hung attention layers. In the word encoder, we use a forward and a backward gated recurrent unit to capture the word informations. For each line, each vector is computed as a weighted sum of the embedding vectors of the host beyond their importance. We do a similar process for the line encoder, the line attention, the hung encoder, and the hung attentions. And the embedding vector of each file in the code chain is computed as a weighted sum of the embedding vectors of the hunks. So after extracting the features from the remove code and the edit code, we put them to the comparison layers. The goal of the comparison layer is to build a vector that can capture the difference between the remove code and the edit code. And we use the multiple comparison function to represent the different angles of the comparisons. The comparison function include the neural tensor network, the neural network, the cosine and Euclidean similarities, the element-wise subtraction and multiplications. So after extracting the features from the file in the code change, we concatenate them to build a vector representation of the code change. And this vector is fed to a hidden layer to produce a work vector. And our target is that we want to build a work vector which closest to a set of words extracted from the log message. And the objective function used to learn our model's parameter is similar to the gross entropy loss function. So in this formula, the yi represent the word and the big Y represent the set of words in the log message. We run the CC2vec on the three different tasks. In the first task, log message generations. To use the CC2vec for this task, we propose a new approach, which is similar to the prior approach, the NNGAN. However, instead of treating each code change as a bag of words, our approach uses code change vectors produced by the CC2vec, and the results show that our approach, the log-GAN, outperforms the previous work on both original and clean dataset. In the second task, the CC2vec is first used to learn a distributed representation of the code changes on the whole dataset. All the batches from the training and the test dataset are used in the log message of the test dataset and at the target of the task. And to use the CC2vec in the batchnet, we concatenate the vector representation of the code change extracted by the CC2vec with the embedding vectors extracted by the batchnet to form a new embedding vector. And we did a similar thing for the LBU SVM. And the results show that the CC2vec helps to improve the performance of the bug-fixing batch identifications. In the last task, just-in-time defect prediction, similar to the previous task, the CC2vec is also used to learn the distributed representation of the code changes in the whole dataset. And to use the CC2vec with the DeepGIT, for each commit, we concatenate the vector representation of the code change extracted by the CC2vec with the embedding vectors extracted by the DeepGIT to form a new embedding vector. And the results show that the CC2vec helps to improve the performance of the just-in-time defect prediction problem on both Qt and the OpenStack dataset. In conclusion, in this paper, we present a CC2vec deep learning model that can produce a distributed vector representation of code changes. And our model takes advantage of the log message and the attention mechanism in the code changes. And we saw that the CC2vec can be used to improve the performance of the software engineering tasks related to the code changes. It's also the end of my talk. Thank you for your attention.
Okay, so great talk. Thank you so much. So now I think we have a question. it is on Slido. What is the impact of using HAN, for example? As in the PassNet, commits can be encoded via 3D CNN. Have you tried replacing HAN with 3D CNN?
Yeah, thank you. I think it's a great question. We also talk about the 3D CNN, but for this paper we haven't tried to do it yet. But because the weakness of the 3D CNN is that they cannot capture the difference between the hung, the number of code tokens, and the number of lines. So that's why we consider the hierarchical attention mechanism in this paper.
Yeah, there is another question. For example, could CC2 make use of the context of made changes surrounding lines, file names, etc.? Could some AC tags benefit from this information encoded in the vector?
I think it's possible. But the thing is that because for each task, we will have the difference, the format of the data structure of each task may be different, and so in this case, for each task, if we want to use the CC2 maybe we need to reformat the data set. But it is still possible if we have to deal with the task related to the code changes.
Okay. Yeah, there is another question from Michael Perdel from University of Stuttgart. Did you consider an autoencoder like training objective instead of predicting the words in the commit messages?
Oh, great. Yeah, actually we consider it in the beginning of this project, but actually it's very hard to predict a word in the log message. And when I run some experiments, the result is very bad. So that's why instead of consider the word, we consider the set of words in the log message.
Okay, we have one more question. Did you only consider the size of the code change as input, or also particular code information like change import statements, etc.?
In this paper, we only consider the information of the code changes.
Mm-hmm. Okay, one quick question. Another question is, what is the efficiency? For example, how long does it take to train or to predict?
Okay. Yeah. I have to say that it depends on your data set. So if your data set is too big, so it will take a lot of time. But thanks to we have the GPU, so we can train the CC2 on the multiple GPUs. For example, you can process your data in a parallel way, so that you can put your data in a multiple GPU and train at the same time.
Mm-hmm. Okay, so thank you so much, James Tong. It was a great talk and very interesting. A lot of questions, and
thank you.
I think you will get a lot of interest in the paper in the coming days or months, with maybe a lot of citations. So thank you. Our next presentation is on code duplication on Stack Overflow, and that would be presented by Sebastian Belts from the University of Adelaide. And we will start as soon as we are ready. Thank you. Yeah. So Sebastian, yeah, go ahead.
Hi, my name is Sebastian Baltes. Welcome to my near talk about code duplication on Stack Overflow. Before I start, I want to briefly thank my co-author, Christoph Treude, and then motivate why we need yet another study about Stack Overflow. Well, interestingly, there's one important aspect that previous research largely ignored. That is the influence of code duplication on Stack Overflow from a community perspective. And in this talk, I just want to briefly outline two possible scenarios. The first is that a user might use code clones to increase their reputation. So they could just use a rather successful snippet in multiple answers without referencing the individual answers or like the original first answer on Stack Overflow, and they would do this to accumulate views and upvotes and in the end reputation. And this is not just a hypothetical scenario, it actually happens. We found several instances of this. For example, this snippet here, first usage in 2016, and then since then, at least 31 copies of the exact same snippet in multiple answers, mostly by the same user. And now just imagine there's a bug in the snippet, and then the user has to go to 31 copies to update the snippets. And it's very likely that this won't happen, or that there will be some kind of mistake, or one of the copies is forgotten, etc. So it has also implications for the maintainability of code on Stack Overflow. And in the second scenario, a user might copy code from external sources into Stack Overflow just to make the answer more attractive, to, again, make it more likely to get upvoted, to increase their reputation. But Stack Overflow's recommendation is actually to just summarize external sources and then put in a link to the source. And again, we find multiple instances of this. For example, there are many code snippets from the Android developer documentation on Stack Overflow. And you have, of course, potential licensing issues here. For Android, it's Creative Commons attribution. So you have to provide a link to the original source. But of course, the maintainability implications are, again, the same here, that if the external source changes, it's not automatically propagated to Stack Overflow, of course, and then you have outdated code on Stack Overflow in multiple copies. But there are also certain issues when you try to address those scenarios. The first thing we observed is that authors actually might reject your edits because they have the right to reject your edit if you try to add attribution, or if you try to add a link to the original answer on Stack Overflow. And the second thing is that due to Stack Overflow's rate limiting, you might not be able to do a bulk edit to add attribution to a bunch of snippets, actually. So most likely your edits would be reverted overnight, actually. What we did is community involvement. We added a post on Stack Overflow Meta that is still being actively discussed about how to handle those two scenarios, basically. And we also built a first very basic tool that helps you to look at code snippets on Stack Overflow to see all their copies, but also external links to judge whether they might have been copied from an external source into Stack Overflow. And in the near paper, we also have a very brief first empirical analysis on this that can be easily extended in the future, adding more sophisticated code clone detection, etc. And if you don't have access to the XC proceedings yet, you find a preprint of the paper on my website. Thank you very much.
Thanks, Ashwin. So, like for Stack Overflow, you noted that you studied clones, and you also looked at fast copied and then to the last one. So, did you also track whether the code actually changes over time by that person, or
there are also edits to the code? Actually, in our MSR paper 2 years ago, we looked more into the evolution part of that. But here for this study, we actually focused more or less on almost exact snippets to get a first idea of how frequently this copying and pasting happens, and to be sure that it's actually the same snippet and not variation. But I'm sure once you consider small changes to some of the copies, you will find much more of those duplicates. Because
that means did you only look at exact clones kind of thing?
Almost exactly. We did some basic normalization, but we didn't really use the sophisticated code clone detection tool, and we already found quite a few copies. So I'm sure when you add this,
yeah, because like you were talking about bug, right? So maybe that bug was fixed or something. So if you could have looked at the differences, and if you could have looked at whether they are actually related to a bug, that would have been a very good study. That over
yes,
time,
definitely.
By the,
I mean, the idea of the near paper was more to make a community aware that there are also issues. So there might be motivation for users to tweak the system in that way, and we can use code clone detection to fix this. But so the focus for this paper was not so much on the technical aspect on to actually use a very sophisticated code clone detection approach, and therefore we focus on the exactness. But I agree with you that this should definitely be done.
Okay, so thanks. Yeah, we have it on. I can say there's some questions now. So can snippet clones be considered as something good rather than bad? Just quick answer maybe.
I think in this case, not really, because when you have one answer containing the snippet, you should just point to that answer instead of copying and pasting the same snippet all over Stack Overflow.
Okay, and also, is there mass code cloning going across different Stack Overflow variants like English, Portuguese? You know,
oh, that's actually a good point. We didn't look into that, but definitely an interesting thing to consider.
Okay, so another one is Risha, Akhilar from Risha Lab. So it's was there a correlation observed between user nature and the user action on code clones?
So I didn't get the first part. Between?
The nature of the user nature and user action.
No,
so what kind of user maybe and what kind of tasks they do?
No, we didn't look into this, but also an interesting suggestion, definitely.
And how many of these duplicates are there like that are kind of generic examples?
We focused on the ones having a certain length and a certain complexity. So we didn't consider very simple, very short snippets. It was more in the, so like the examples I've shown you, a couple of lines, whole methods, classes, etc. in that regard. But it's again possible to extend this also for shorter snippets.
Okay. Thank you so much, Sebastian. It was a great talk and very interesting. And I read it already, quick look, but I will read it again and I will ask my students to read your paper and hopefully read more. Yes, our next talk is a journal first paper, which is also on clones and should be very interesting. It's kind of talking about scalable and incremental code clones search via multiple code representation. And I will let Chae-Young to talk about more on it and that name of the tool. Chae-Young, yeah.
Hello. Is the sound okay now?
Yeah, please go ahead. Yeah.
Okay. Yeah, sorry. So this is Siamese, the scalable and incremental code clone search via multiple code representations. This is journal first is published in Empirical Software Engineering, and this is the work I co-author with Jens Krinke from University College London. So nowadays, we are in the need of code clone search system. So imagine that the developer today, they use a lot of source code from the internet. So there's a large number of source code that currently proliferating on the internet, such as Stack Overflow or GitHub. And the developer also prefer to use these code snippets, which are solutions from online sources, such as Stack Overflow, and they copied it to their software projects. There are also some studies that use these online code snippets as suggestion to developers during their development. So these code snippets may be clones to the software projects. However, there are also studies to show that these cloning from online sources may also introduce some negative effects, such as license violation or introducing software vulnerabilities. So in order to tackle this issue, we try to come up with an approach that is scalable enough to the large-scale data on the internet and can search with accuracy. So our approach is the Siamese clone search that has the following benefits. So the first one is the multiple code representation. Siamese use multiple representation of the same source code to capture different types of clones at the same time. It also uses a technique of query reduction to improve the clone search accuracy by keeping only rare terms in the search query. And Siamese also provide clone ranking that allows the user to adjust the ranking of the clones so that they can select specific types of clone to be ranked on the top of the search result. And the last one is it has incremental updates. When the code search index is large, they can add or remove specific project into the index very quickly. Okay, so let's start with the multiple code representation. So let's say we have this code snippet example on the left, the binary search method. When it is fed to the multiple code representation module, Siamese is going to generate 4 representations of the same source code. Each representation captures different types of modifications that can be made to clones, such as variable renaming, different literal values, or added, deleted, or modified statements. So by having these 4 code representation, we pass them on to another module, which is query reduction module, that analyze the frequency of the code tokens in the code search index. So showing on the left is the plot between the document frequency of the terms. This one is for Java, according to their rank. So the most frequent terms are on the left. So Siamese only keep the rare terms that are highlighted in green here and get rid of the frequent terms from the search queries. So by having these rare terms in the search queries, we can improve the accuracy of the clone search. So after that, the 4 queries will be combined together, and by adding the weight into each representation, we can select what specific type of clone that we want to get in the search result. So let's say if we have modified the weight to be like this, then the ranking of the clone can be changed. Okay, we have evaluated Siamese in multiple aspects. So the first one, we have checked whether the multiple representation and the query reduction can improve the clone search accuracy. And we have found that by using MR and QR, we get the highest mean average precision compared to using MR or QR alone and compared to the baseline text search. And by comparing to other clone detection tools and also the text search engine on 2 different data sets, we found that Siamese give the highest result in terms of mean average precision when searching for clones. And by modifying the weight, we can boost Siamese to look for alternative implementations or type 3 clones in this case. It gives the highest MRR score compared to the default Siamese with the default setting and compared to the baseline text search. And the last one is Siamese can scale to large index of million lines of code and still give the result of clone search within seconds. So it has quite comparable performance to Sorcerer CC. So we have tried to apply Siamese to the following tasks, such as online code cloning detection on Stack Overflow and online clone search with software license analysis. Siamese can also be applied as a clone search as a service. And lastly, I have recently used it to detect the usage of Pythonic idioms in software. So that's it for the talk. And if you are interested, please check out the paper and the tool here. Thank you.
Great, thank you, Chaiwang. So we have a question. It says, can you detect code clones in different code modularities, like detecting 2 methods of quick sort that would be semantically the same as one merge sort method?
For now, no. So Siamese works on 2 granularities. The first one is method level, and the second one is the file level. Yeah, that's a good idea, and yeah, we may consider it for the future work.
And another question is it kind of, can some people use it online, try it online? Is it only limited to Java, or do you have other support?
Okay, so the tool is available for download online, and it now supports Java and Python, and we are adding more languages to it. So please check out the link in the GitHub repo here.
Okay, great. I think because of the time, okay, I will take one more question. So generally, Stack Overflow questions, Stack Overflow suggests similar questions. Have you compared your code clone search with the suggested questions?
I'm sorry, can you repeat that?
So generally, Stack Overflow suggests similar questions. Have you compared your code clone search with the suggested questions?
Yeah, I'm not sure I understand the question correctly, but what we do with...
Yeah, so maybe, I don't know, you can reply to that comment later on.
Yeah, we take it offline. Thank you.
Yeah, maybe I have to actually stop it for the sake of time. So thank you again. So we will move to the next presentation. And that is again another journal first. And that is on empirical comparison of text-based mobile apps similarity measurement technique. And that would be presented by Afnan from Monash University. So let's go ahead, Afnan, whenever you are ready.
Hello, can you hear me?
Yeah.
All right. Hello, everybody. This is Afnan Subayhin. I'm an assistant professor at King Saud University here in Riyadh in Saudi Arabia. I'm here to present our journal first, published at MC in late 2019. So in this paper, we present our work comparing similarity detection techniques for mobile apps using text-based artifacts. But first, let me introduce the problem. So app stores seem to now pose as the main software deployment repository for mobile apps. This research by Lim and others found that less than 1% of about 5,000 respondents did not refer to the App Store for app installation and discovery. So it seems that app stores do play a huge role in that arena. So this prompted a previous study that we looked into how exactly app stores are affecting any of the software development lifecycle stages and whether they introduce any new best practices, skill sets, success criteria, or measurements. We indeed found that many or more than half of the respondents indicated that they frequently do survey similar apps on the App Store in order to elicit requirements or even discover new enhancements for pre-released apps. However, finding these apps in the first place might not be a trivial task. App stores house a large number of apps ranging between 1.5 million and 2 million apps. The app categories convey a broad theme of the app, but not really functionally similar app. This is confirmed by previous research, which found that app store categories are not sufficient to find functionally similar apps. Just to illustrate this problem, both Elevate and Blackboard belong to the education category in the App Store, despite the fact that they share very little functionality and services that they provide to the user. On the other hand, a more similar app to the Elevate brain training app, which is Cognifit, can be found in an entirely different category in the App Store. So we thought, could we look into the descriptions of these apps and find a better categorization in which we can categorize Blackboard with Google Classroom, for example, and Cognifit with Elevate just by looking at their advertised features. In this research, to investigate this problem, we investigated the performance of 5 different feature extraction techniques, which are the baseline, the vector space model with TF-IDF weighting. We looked into also the VSM model with latent semantic indexing. We also investigated using topic modeling with LDA. We investigated our previous keyword-based extraction technique that looks into collocating word and extract them as advertised feature. And then another also keyword-based extraction technique, which we called here FSM dependency, which performs dependency parsing of sentences in the description and finds specific patterns of sentences that are more likely to be advertising feature. So we investigated this over a sample of app. We completely uniformly, randomly sampled around 13,000 apps from the 24 categories of Google Play in 2014. And we looked into several research questions. We wanted to compare those techniques based on 3 main criteria. First is the qualitative cluster quality, which we measured using the silhouette score of the clustering. The silhouette score is basically a score that qualitatively assess the quality of a cluster, and it ranges from -1 to 1. And also we investigated human judgment of the resulting clustering solutions, and we also investigated the execution time. So to look into these research questions one by one, we have the first research question, which was only a sanity check. We measured the Jacquard similarity of the clustering solutions of the 5 investigated techniques, just to make sure that they are different. And indeed, we uncover that they are different. Perhaps the most similar is the collocation-based keyword extraction with the dependency-based keyword extraction. The second research question looks into considering the current App Store categorization as a clustering solution, and then measuring its quality using the silhouette measure. And based on that, we found that it is indeed of very low quality. When we take a look at our clustering solution at that granularity, when k equals 24, it indeed improves on the current categorization of the App Store, but not by far. So that prompted the next research question, which asks, then what is the most suitable K for each of these feature extraction techniques? And we find that an LDA-based feature extraction achieves the highest silhouette, the highest quality, the highest clustering solution at a very high K, almost 5,700. We also note that using the vector space model with LSA can achieve a passable clustering quality at a relatively lower K, 112. The following research question asks, what is the quality of each of these clustering techniques, but based on human judgment? To do this, we asked 8 human raters to rate randomly sampled app pairs, to rate their similarity from 1 to 5. And then we looked into when do these app pairs, when do they separate in the clustering algorithm? For example, if they separate at k equals 30 versus they separate at k equals 30, it means that they were less similar. So we calculated the inter-rater agreement. It's a passable agreement, but it can be very low. So basically what we did is we asked these human raters to rate based on 3 criteria: the feature similarity, the application domain similarity, and the API similarity. And the API has the less inter-rater agreement. But in general, we find a relatively high correlation. Okay, so finally, we measure also the efficiency of each of these techniques. As to be expected, algorithms that produce good results require more costs, so it's a compromise that should be considered. So the findings of this study is that indeed we can improve on the App Store categorization by using these extraction techniques. App Store categorization is not a good clustering solution. We also find that the silhouette score in itself is not a sufficient measure of cluster quality. Human judgment must be employed. Using any of these techniques enhances over the baseline, which is the vector space model. Using LSA helps it to converge to a coarser granularity, a lower K. App similarity can be challenging even for humans. So to conclude, descriptions are an important source for developers from which they perform requirement elicitation and keep abreast of user expectation and application domain. Finding functionally similar apps may not be trivial though. App Store categorization have been found to be inadequate. This study looks into clustering mobile applications based on their textual descriptions. It measures the applicability of 5 common feature extraction techniques. We uncover several findings that are helpful for carrying out this task, either for practitioners or for researchers. Thank you very much for listening.
Okay, so thank you very much, Safan. So, like, you only looked at text-based, okay, right?
Yes,
not other techniques. Maybe I will take questions from Slido first. So can you, the first question is, can you conjecture why the App Store categorization is so poor? Why do you think the App Store categorization is not really good?
I think it's because of the nature of app stores. They are not to help developers. They are mostly to help users to discover apps. And users mainly do not discover apps by selecting a category first and then browsing it. They usually use keyword search. So I think the App Store categorization is neglected. It's okay. Not the best that it can be. Yeah.
So another quick question is, which clustering algorithms have you used for clustering? Have you tried different variations like single linkage, complete, or word?
Yes, thank you for this question. I didn't have time to go into the technical details of our study. Please do look into the paper. So we use hierarchical technique, and we did try the single, complete, and we found that word-based criterion performs the best. So that's what we went with.
Okay, so there's one more question I can take. There are some apps with simple descriptions which may not be able to extract the semantics. So how to detect such apps?
That's true. That's always going to be a shortcoming of just using descriptions. So in general, using descriptions is very cheap. Descriptions are readily available, but this comes with its own drawback, which is that sometimes app developers do not pay too much attention or spend much time in explicitly working on their app description to be properly describing the app. So yeah, that's indeed a shortcoming. Of course, in our sample, we made sure that these apps have adequate, long enough descriptions just for the rigor of the study. But if it's going to be applied in general, these shortcomings should be taken into consideration.
Okay, so thank you so much, Afnan. It was a great, I think, empirical study, so people could learn from your work.
Thank you.
Yeah, thank you. So our last talk is actually a demo talk, which will be a 3 minutes demo teaser kind of thing, and that would be on mining analogical APIs for library migration. That would be presented by Chin-Young Chen from Monash University. So Chin-Young, please go ahead whenever you are ready.
Yeah, thanks a lot for the introduction. So thanks for coming to this talk. Today, I'd like to introduce our latest work about mining similar APIs across similar third-party libraries. So first, I'd like to introduce some background of this work. We know third-party library is pretty important for the software development. But sometimes we may find some issues with your libraries, like it may be out of date, the library is no longer maintained, or there are some crappy bugs with the library. So at that time, you may want to replace the old libraries with some new third-party libraries, and that process is called library migration. But for each library, we know there are many APIs. So when we are migrating the libraries, actually we are migrating the APIs. But finding similar APIs across similar libraries actually is quite difficult. So in this work, I propose an unsupervised method to find similar APIs between similar libraries. So for each API, we model 3 kinds of information, including the API call sequence, the method, the API name, and API comments. So for these 3 kinds of information, we use 2 models. We use the continuous skip graph model to model the API call sequence semantics. So we map the API to one vector in the vector space. And for the method name and the method comments, we use skip sort to map it to a vector in the vector space. So finally, we got 3 vector space. So given the inquiry API, we will locate its vector in all these 3 vector space, and then we will check all most related API candidates in all these 3 vector space, and finally we combine the similarity to infer a list of most similar APIs in the target library. So that is the way how we find the similar APIs across the similar libraries. So we implement our algorithm into a real website, and you can visit this URL to try our tool. So finally, it recommends analogical APIs for 583,000 APIs of 111 pairs of analogical Java libraries. So you can see across the world, there are some developers are using our tool. It somehow demonstrates the effectiveness of our tool. But due to the time limitation, I cannot explain more about the approach and the evaluation. But actually, this paper is based on our TSE paper, the Transaction on Software Engineering paper. So if for more details about approach and evaluation, you can come to read our TSE paper. And if you have any questions, just feel free to shoot me an email. And thanks a lot for coming to this talk.
So thank you so much. I think it was a great tool. And my question was, are you going to also present the tool at some point? Maybe you can let the audience know when you are going to talk about it.
I think I just show my tool in the slides. There is a URL, and you can click that tool.
Will there be another? I mean, will there be another presentation by you at some point at XC or no?
No.
Okay, so maybe we are also about the time. So I have a quick question. So with your tool, you are looking at 3 different dimensions.
Yes.
Like, did you also like look at like which dimension is the most effective, which one is not really effective, or
yeah. So that is a pretty good question. Actually, we have look at that part. So I need to share it with. So you can see here I show one table. So I compare different derivation of different different information, and you can see the performance when we are incorporating different information to that model. And actually, that paper is quite far. It's quite old. So I remember the name is the most important information actually compared with the other two.
Okay, so okay, and like in your learning, what was like how much the data set did you use?
Yeah, that is a very good question. So actually, you can see this is the data set we use. We crawl a lot of Java GitHub projects. So it's 135,000 Java projects.
For the learning and for I'm talking about in particular for learning. So you learn from all those things, like.
Yeah, that's right. We use that to learn the model. But when we are constructing the analogical API lab tools, we just use that one. So this is for the.
So I think we are almost done with this session. So I thank you all the speakers of this session. We had several great talks on clones and changes, and thank you all other participants. Thank you all the Zoomers and all the like ICSI participants as well who are with us for this session. And if you have any questions, all the papers are I think available. Journal papers are of course available, and the ICSI papers are also available. Please look at their papers and feel free to enjoy reading them.
Yeah.
So that would actually end our session. Thank you all again.